Right, so today, oh, there's some more chat. What kind of traversal is it? Traversal? Okay. Right, and I have to put this on. I have to put this on airplane and start. Right, I have to put this on airplane. And start the timer. Good, we're going. Sorry, I'm gonna turn on the chat and looking if it's about this. What kind of question and answer? Can you be Mr. Klages during these? I'm not even sure if I. Oh yeah, it's a virtual exam. So how do I make the question and answer go away? Okay. So last year I was pretending that I was this super relaxed professor, but okay, so that's recording. So today we're going to try to get through 3 topics, 2 of which are not super hard, and the third of which is kind of tricky. But I did the course notes, so nobody wanted to write up the scribe notes for optimal binary search trees last year, so I ended up doing it. Although later I wasn't going to write scribe notes for all the sessions that people didn't want to cover. So there are some topics that just, we have no scribe notes. So I'm going to check, I have my scribe notes on the laptop so I can check this. Okay, so the first problem we're going to talk about is something called subset sum, which is a bit like knapsack but easier. Okay, so for subset sum, you get, can people see the, yeah, okay. You get a bunch of numbers, say 2, 5, 8, 9, 11, 17, and then you get a target number, which let's say is 25. Okay? Why did I make angle brackets? Let's make this round. Okay, so this is an instance of subset sum. So these are just some numbers, and this is your target. And the question is, can you add up, can you pick a subset of these numbers that add up to this number? Okay? So that sounds, I mean, everybody sees that, right? Okay, I'm going to turn the chat on so I can see what people are saying. Okay. So, I mean, for this instance, you could just sort of eyeball it and say, yes, probably there are a bunch. Maybe there is more than one way, but at least I hope I didn't make a mistake. I picked a couple. So, but how are you going to do this? Now, actually, this problem is technically a boom problem. Okay, this is actually a hard problem. It doesn't look like that, and I'm about to teach you a dynamic programming algorithm for it, which runs sort of in polynomial time. How is this not a contradiction? Well, it's going to run in time polynomial in the size, in the number of numbers, which is fine. And it's going to run in time polynomial in this. Actually, it's going to have like a linear factor in terms of this. Now remember that that we measure the size of how big is this instance? Well, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 digits. Right? So it's something like 10, and then okay, you have the commas and stuff like that. But it's something like the number of numbers, and how much space does each number take, like logarithmic space to write down. I didn't actually need space 25 to write this 25, so the size of my input is not proportional to this. This is only contributing a logarithmic factor. So if I have a program that has a factor 25 in the running time, that doesn't mean it's really polynomial. It's polynomial in 25, but it's not polynomial in the size of the instance. So that's why this is a boom problem, but we're about to see a dynamic programming algorithm for it. So the key to dynamic programming is sort of figuring out what you want to compute at each step, right? So what is a cell of your matrix going to mean? What are you figuring out? And sometimes you need something, sometimes you just need, you need like, okay, what's the answer? The answer is going to be this. Okay, then I'm going to compute that for every sort of sub-problem. But sometimes you need something, you need more information about the sub-problems. But not here, I think. Okay, so does anybody have an idea of what our, how many dimensions is our matrix going to have? So, oh, okay, before I ask that question, I should tell you, you're only supposed to use each of these numbers once. In standard subset sum, it's a subset, it's not a sub-multi-set. Okay, you're not allowed to say list size by list size. Could you do it that way? Not sure how to do that. So list size by something, yes. So, okay. To keep going, what we're going to have is, this is going to, let's see, this is 1, 2, 3, 4, 5, 6. What we're going to have is a matrix which is size 6, and this is where this gets not so efficient. It's going to be size 6. Why did I make this 25? That's annoying. Let's make this something smaller than 25. Let's make this 15. Okay, then it's kind of, let's make this 12. Okay. Just so that we don't have quite as much stuff. Okay, so this is going to be size 6. And this is going to be 5, 10, 15. Actually, maybe I'm going to need another one at the end just to be... Okay, so, actually, maybe I'm going to need another one on top. Just to make this really easy to fill in, let's put another one at each end. Okay. So now this is 0, 0, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so you can just get all pair values, so you get, no, but it's not pairs. It's subsets. So can you get 15 with, you don't get 15 with a pair. You get 15 with a triple. So, I mean, yes, you could do this by like considering every possible subset, which is 2 to the number of numbers. But that isn't even polytime in this thing, right? That's just horrible. So what we're going to do is Mij is a Boolean value, is true if let's say that this is x1, x2, x3, x4, x5, x6, and let's call this thing t. So Mij is true if we can select a subset of x1 to xi that sums to j. And false otherwise. And I should have written this over here so I could write the program here, but okay. So, can we choose a subset of well, nothing that sums to nothing? Yes, we can. Okay, I'm actually going to fill this in red. Okay. So this is true, right? Everybody sees that's true. Okay. Can we get a subset of rows? Yeah, okay. Rows is right. Rows is supposed to be the numbers. Columns is supposed to be. So can we get a subset of nothing that sums to 1? No, right? We can't get a subset. A subset of consisting of nothing, of nothing, x1 to x0 is the empty subset. So this is false, and 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 this is false, 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 false. Did I start the timer? No. Oh, yes, I did. Okay, 13 minutes. Just making sure this is recording because I'm paranoid. It's recording. Okay. Okay, so now, can we choose a subset of x1, the singleton set x1, that sums to 0? Yes, you don't choose anything. So this is true, and 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 this is true. No matter, like, if I said, oh, can you choose a subset of x1 through x6 that sums to nothing? And you'd be like, yeah, I don't choose anything. Okay, so now we have to figure out if you know. Oh, so usually I should have flipped this around. I've reversed the usual matrix. Now I'm doing sort of xy between the 0 row and 0 column. Okay. What is this cell asking? It's asking this. Now, okay, usually you count down, and I've accidentally done it counting up. Does anybody want to stop? And in the lecture notes, I'll do this properly. I'll switch it around. But let's say that this is, this is 0, 4. Okay? So this cell is 0, 4. This is M, 0, 4. So that's asked. That should be true if we can choose a subset of x1 through x0, so the empty set, that sums to 4. We can't do that. We can't choose nothing and have it sum to 4. Right? Maybe we could choose a subset of bigger set and have it sum to 4, but we can't choose nothing and have it sum to 4. So this is false. In fact, all of these are false. In the lecture notes, I'm going to turn it upside down, so it's not. Now I'm doing xy for some reason. Okay, so how are we going to? Yes, we can choose 4, 0. 4, 0 is can I choose a subset of x1 through x1, x2, x3, x4 that sums to 0? And you're like, yes, I can. I don't choose anything. And then it sums to 0. So this is all true. You can always choose a subset that sums to 0. And this is true, and then the rest of the row is false. Okay? So now, the question is, if I have, if we have, okay, that doesn't look like an M. M I minus 1 J M I minus 1 J minus 1 M I J minus 1. Can we fill in Mij? And the answer is not exactly. Okay? We don't just need these. Okay? We did for edit distance. Remember, edit distance, we just looked at the blocks above and to the left and to the left. But now, this isn't going to quite work. Okay? Because now, actually, what we're going to say is, if we have we need M. Unfortunately, after I erase, oh foo. This is a little bit damp, so I'm just going to get a piece of paper. So what you actually want is to work out Mij. You actually think, well, I can work out Mij. If you think about it, well, either you take xi or you don't. Okay? Right? So this is going to be, don't think about just the stuff above and to the left. But if we take, if we take xi, then we can get some j if we can get some j minus xi from a subset of x1 xi minus 1, right? So if we decide to take xi, then, so this means that if we take xi, then Mij equals Mi minus 1 j minus xi, right? But that's not the only option we have. If we don't take xi, then we can get j if sum j from x1 xi, sum j from x1 xi, if we can get sum j from x1 xi minus 1. So actually I should have written this in red so that it stands out. So I is the number of elements in the subset, and j is not, well, j is the target value at the moment, right? Is the target value for that cell. It's not necessarily the target value for the whole instance. Because when I'm filling in this cell, I want sum 7. When I'm filling in this cell, I want sum 10. Only when I'm filling in this cell do I want the, well, this cell or 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 this cell, do I want sum 15. Okay? So the thing is, if we take this one, we can say, well, we can get some mij is true if we can get some j minus xi from from x1 to xi minus 1, or mi minus 1, or if we can get some j from x1 to xi minus 1, then we don't need xi, right? So this is mij is true, is the disjunction of these two things, okay? So you say, if one of these two things is true, then this is true, otherwise it's false. Good? Okay, so this is an or. Can people read that? Okay, so let's just sort of fill this in a bit. Actually, I'll leave that there. So, what is now the, oh, I forgot to announce. If you take j and you subtract xi and it's negative, then we're just going to assume that the answer is false. Okay, that saves me having to write a load of falses over here. Okay? So, what is M11? So that's asking us, can we get, so M11 is asking us, can we get a subset of x1 that sums to 1, exactly 1? No. Okay. So this is going to, but instead of just thinking about it, we're going to do this automatically and say, okay, well, what is mi? This is true if we can get some minus 1 from the empty set, right? So we're here, which is x1, but then we subtract 1, so we're asking about the empty set, but it's over here. It's minus 2. Sorry, it's minus 1, because we're asking if we can get j is 1, x1 is 2, and so we can't get this. This would be m0 minus 1, and that's false. And then we're asking, okay, well, in that case, can we get some 0? This is m0 1. And so we look here and we say, no, that's false too. So this is false. Okay? Now, what about, yeah, well, this is maybe more interesting. This is asking, can we get exactly 2? Can we get sum 2? Okay.